Welcome to the video on graphing quadratic inequalities of two variables. In this video, I'm going to give you two examples of graphing a quadratic inequality of two variables, and we'll discuss in great detail how to go about doing this in kind of a step-by-step fashion, and also kind of related to something that hopefully you remember how to do, so it'll make it a little bit more simple for you. Let's go ahead and begin our first example. Example 1. We're going to try to graph the following inequality: y greater than or equal to x squared minus 4x plus 1. Now notice this is not an equation, it's got an inequality as the relationship between the y and the x variable. So going about graphing this is similar to when we were graphing an equation, but we have a slight bit of different steps. So let's write them down. Step 1. Step 1. Let's make sure that we graph the quadratic equation. So similar to how we did this for linear inequalities, we're going to first pretend that we have an equation, y equals x squared minus 4x plus 1, and I'm going to graph just that relationship when y is equal to x squared minus 4x plus 1. Now within this step, we have to remember some of the methods of graphing from the different forms. Now considering this is in standard form, and I can see my a value is 1, my b value is negative 4, and my c value is 1, if you recall, getting the x-coordinate of the vertex, or the axis of symmetry, from standard form was using this formula, negative b over twice a. In this example, negative b is going to be the opposite of negative 4 over twice the a value, 1, which is really positive 4 over 2, and I get an x-coordinate of 2. Remember, for your vertex, we just found the x value. To get the y value, we need to substitute 2 in to the x values in our original relation. So if I get y equals, I'm going to put 2 squared minus 4 times 2, and then it was what, a plus 1. That's going to be 4 minus 8 plus 1, or negative 4 plus 1. I get a negative 3 output. So there's my vertex. Let's graph this. Let's see if we can make enough room on here to get this done. Oops. I don't want that. Let's use a solid line. How about this one? Here we go, looking a little bit better there. That's our y-axis. That's our x-axis. And now let's plot that coordinate, 2, negative 3, over 2, down 3. Oops, right here. Remember, axis of symmetry is right down the vertical line that passes through the vertex. That's our axis of symmetry, and we would want to plot a couple more points to shape this guy. Just to make this a little bit easier, let's pick some easy values like x equals 0, right? If I plug in a 0, I would square 0 and subtract 4 times 0. That just turns into 0, and I get plus 1. I get a y value of 1. So if I plug in 0, I get out 1. That's that point right there. Using symmetry, I'd have to count 2 units to the right, and I'd also get that point. Now, when I graph this, I have to be careful when I graph this. If I have a greater than or equal to or a less than or equal to, I can use a solid parabola. If, on the other hand, I have a strictly greater than or a strictly less than sign, then I'm going to use a dashed parabola. So these are like kind of the two things to keep in mind when you graph your parabola. Now in this case, check it out, I got a greater than or equal to sign. That means any points that are located on my parabola or equal to that parabola, these are solutions. So I would want to make this a solid line. So that's what I'm going to go ahead and do, make a nice solid U-shaped graph. That's step 1. Step 2. Step 2, I have to figure out where are the other solutions. This is an inequality, meaning not only do I have any point on my parabola as a solution, but there's going to be either the region inside the parabola where the other guys are or outside. So this is kind of the rule of thumb I use. If we have a y greater than or y greater than or equal to sign, I'm going to shade the region that is above the vertex. If, on the other hand, I have y less than or y less than or equal to, I'm going to shade below the vertex. So let's check out what we have in our example. In this particular example, I go back to my inequality, which was y greater than or equal to. And since that fits this first case, I know I'm going to shade above the vertex. So what does that mean? Well, above the vertex, since this is my vertex right here, right, anything above it is up above. So that means I can shade anything inside of this region here. Maybe I can make this a little bit thicker. There we go. So I can shade anything inside of this parabola. What I'm showing then, if I choose any coordinate inside here, let's say it's that coordinate, which looks like it's, what is that point? That'd be 1, 2, 3 for x, and then 1, 2, 3. That's the coordinate 3, 4. Since that coordinate lies in my shaded region, that should satisfy the original inequality and be a solution. I'm going to leave that for another time to show, but if I were to plug in a 4 for y and a 3 for x, I would end up with a true statement, a true inequality. And the same goes for any other coordinate in this yellow region, or as a matter of fact, on the parabola. If I pick any of the points that are on the parabola, it will also satisfy that inequality. Let's do one more example, because the more examples you see, kind of the more things will make a little bit of sense. So let's take a look at this. Let's try to do y, and just to make this easy, let's do y greater than, or just strictly greater than, let's go negative x squared, just to get the idea here. Remember, we're going to try to graph this thing first. So if I graph this, I'm going to get my axes going. See, this is my y-axis, kind of missed that grid line there, but it's not too bad, so we'll keep it. So let's say this is my graph. If I'm graphing this, I'm first graphing y equals negative x squared. Well, this is technically standard form, or even vertex form if you want to think of it. Let's write down the a value, negative 1, the b value, 0, the c value is 0. If I use my negative b over twice a, it's going to be negative 0 over 2 times negative 1. That's just going to be 0, right? So my x coordinate is 0. If I plug in a 0 and square it, I get out 0. So my vertex is at 0, 0. And this thing is going to open downwards. Remember, if there's a negative in front, that's going to mean it's going to open downwards. And if I were to plug in a 1 for x and square it, there's a negative in front, making the output negative 1. So 1, negative 1. And then using symmetry, I'd get that point. I think if we plugged in 2, we would get negative 4. And using symmetry, I would get that point. Before I draw this, I got to keep in mind if it's going to be solid or dashed. Because the inequality is a strictly greater than sign, I do not want to make this a solid parabola. It will be dashed. So I'm going to dash. This is kind of tricky to dash a curve like a parabola. Take some practice and skills. You can see mine is almost perfect. I'm being sarcastic. It's not a very good graph, but it'll do. It's dashed, guys, which indicates any coordinate that's on the parabola will not satisfy the inequality because the y would be equal to the negative x squared value. And we don't want that. We want y values to be strictly greater than. Now, if you recall from the last example, to know where to shade, we have to look at the inequality as well. And since I have a greater than sign, I want to shade above the vertex. Oops, whoa, where did I go? Shade above the vertex. So if I shade above the vertex, that means I have to go somewhere up here and shade. Now this is weird. The region that's above the vertex is up here, but there's nothing preventing me or separating this part of the graph from anything over here. So I can shade all this stuff over here and even go on this side. Where I do not want to be is shading inside the parabola. Definitely not. So what I'm telling you is if I pick any coordinate that's outside, be it that guy, that guy, that guy, that guy, these are all solutions in that yellow shaded region. Anything that's inside the parabola or underneath it here where the x is, these would not be solutions. Just to show you, it's a little bit easier in this example. If I pick that coordinate, we know that as 0, 1. This should be a solution. Let's see it in action. If I plug in a 1 for y, it should be 1 greater than the opposite of 0 squared. Well, 1 is greater than 0, so this is a solution, along with all of the other buddies that are in that region on the other side of the parabola. Real quick, since I have just a little bit more time, I want to show you something interesting. Let's take that same graph, but instead of saying y greater than, let's do y less than negative x squared. We have the same exact graph, right? So let's see if we can quick graph it. Okay, and remember we have the same graph, so I have the same coordinates that I'm going to go through, which were right here. Now, because I have a strictly less than sign, not equal to, it's going to also be dashed, so I dash, 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 dash. That is not as good as the other one, but this will work. There's my dashed parabola. Now I changed the sign to a less than sign, so that means I got to shade below the vertex. Okay, so in this case, if I'm shading below the vertex, here's my vertex. If I shade, whoops, I don't want to do what I just did. If I shade below the vertex, I got to shade under it. So in this case, I'm actually inside of my U-shaped graph. I'm not on the outside. The solutions for this inequality are all located kind of inside of that U. All right. So it's very important that you follow the instructions for shading to the T in order to determine if you're going to shade above or below. A lot of students accidentally take the less than sign for shading on the outside of the graph or the inside. I'll never use outside or inside to figure out shading. It's always either above the vertex or below. So if you're shading below, you're going to be here. In a similar example, I'm just going to plop one down. If you had a graph, let's say, that was opening upwards, right? But it was y less than whatever it is. That less than sign says shade below the vertex. If the graph is opening upwards, well, then below the vertex is underneath, and you could be on the outside. And this is kind of troublesome for some students because in this example, shading below is in the graph. And in this example, shading below is not inside of the U, it's on the outside of the U. So don't think in terms of inside, outside. Think in terms of what is above and below the vertex. If it's a less than sign, you will always shade below the vertex. In this example, below the vertex happens to be inside because it's opening downwards. In this example, below the vertex is on the outside because this one is opening upwards. It takes some practice and getting used to, but ultimately it's the same thing as graphing a parabola, which is knowing how to do if it's going to be a solid or dashed parabola and just determining where to shade. Thanks for watching, and I hope this helps.